Hello everyone, and this is the lecture series of Operation Research subject. The course code of this subject is ME405. This is unit number 5 and lecture number 31. So for today, I will discuss about the topic regarding simulation. So here in this Operation Research, simulation used are the use of simulation, just like as a business and are varied, and it is often utilized when conducting experiments on a real system. When conducting an experiment on a real system is impossible or impractical, often because of the cost or time. So this simulation thing provide one kind of analysis for the case of transportation and other types of related problems. So in the operation itself, simulation are used in different transportation problem, and in case of just like a study of the minimum cost requirement, and the SAP software is used for this purpose. And for this, my introduction, myself Rahul Kumar, Assistant Professor of Department of Mechanical Engineering, Suresh Gyan Vihar University, Jaipur. So in this chapter, I will give the information regarding the simulation study, and what is the importance of simulation and why it is required in operation research, and just simulation in this lecture, simulation just provide as a experimentation on the valid digital representation of the system, and these are the some objectives of this lecture here. By the end of this section, you should be able to understand about the simulation modeling and how it is solved by this real world problem, how this is solved by the real world problem safely and efficiently, and it provides an important method of analysis which is easily verified, communicated and understood for this case. And it provides also industry-oriented approach and discipline of simulation modeling, provides very valuable solutions by giving clear insight into complex system. So with the help of simulation, just we go to the solve the different type of complex problem into the easy way manner. So simulation just provide a one method to solve the real world problem very specific and very efficient manner, and it provides one analysis which is easily verified the result and the understanding of these different types of techniques, right? So it uses different kinds of simulation in different industries, and simulation enables experimentation on valid digital representation of a system. And unlike physical modeling, in the case of simulation, unlike physical modeling, such as making a scale copy of a building, and simulation modeling is computer based and uses algorithms and equations. Suppose in the case of the fluid dynamics, in this case of just you want to find the flow over a building. So means how much drag is created by this building. So in the real world problem, first you construct a building model. Then you apply some sensors and pass the flow inside the fluid wind tunnel. So this is very typical task. But in the case of simulation in the ANSYS software, only just you make a model in CATIA or SolidWorks or Fusion 360-degree software, and then this model you can simulate in this ANSYS fluent flow software, and find the within one day you find the exact result of this problem, and it also provide the way to how much drag, how much flow characteristics, streamline analysis, and all type of situation related to this problem. So, and suppose this is the contents of this lecture. First is introduction, definition, goal of the modeling and simulation, when simulation is the appropriate tool, when simulation is not appropriate tool, advantages of simulation, disadvantage of simulation, area of application, and the characterization of the simulation model. Here are the different types of simulation model are used, and the steps in simulation study and the references for this. So for this simulation analysis, here this is one definition is given in this slide. So a simulation of a system is the operation of a model. Okay. Operation of a model, and the model can be reconfigured and experimented with the operation of the model can be studied, and hence properties concerning the behavior of the actual system or its subsystem. So with the help of simulation, you can divide the very big complex problem into the some small steps, and these steps are called the subsystem. And in its broadest sense, simulation is a tool to evaluate the performance of the system. Simulation is a tool to evaluate the performance of a system and existing or postponed under different configuration of interest and over long period of real time. So in this simulation, this provides one type of hypothetical result. This provides a hypothetical result for this case, and simulation is used before an existing system is altered or a new system built to reduce the chances of failure, to meet the specification, to eliminate unforeseen bottlenecks, to prevent under or overutilization of resources, and to optimize system performance. So simulation provides one way to how to reduce the system performance, how to reduce the system properties. See, just it optimize a result, and it also optimize the system performance, right? So we can say that, in other words, simulation is a software that provide a dynamic environment, for the analysis of computer model. While they are running, are including the possibilities to view them in 2D or 3D case. And the use of simulation in a business are varied. And it is often utilized the conducting experiment on real systems, is impossible or impractical. Suppose in the case of suppose you want to find the density at the 10 kilometers above the Earth's atmosphere. So how it is possible? So this is a very tough case. So just you create a one simulation model and then find the electron density at this 10 kilometer of height, and simulation reduces the cost or time also. It reduces the cost and time both. And simulation is one kind. I can say that simulation is the ability to analyze the model, and it runs set simulation modeling apart from other methods, such as those using Excel or linear programming. So here this simulation provides a very good understanding of this problem, and these are the questions arising by this customers. So simulation can be used to answer all things. First question is here: what is the best design for a new telecommunication network? So it will provide a one way to give the best design for a new telecommunication network, and what are the associated resources requirement, and what are the associated resources requirement. And third is here: how will a telecommunication network perform when the traffic load increase by 50%? If traffic load is increased by 50%, and which network protocol optimize network performance? Which network protocols optimize the network performance? And what will be the impact of link failure? What will be the impact of a link failure? So these are the different kinds of cases arises in this simulation. So, and you can solve these all type of case with the help of simulation study. So here the subject is one subject is here. So in this tutorial I want to use the discrete event simulation, in which the central assumption is that the system changes instantaneously in response to certain discrete event. On the other hand, continuous simulator like flight simulator and weather simulators attempt to quantify the changes in a system and continuously over time in response to control. So these are the different types of system, and then by the for the result of simulation we use the discrete event simulation is less detailed, and then continuous simulation, but it is much simpler to implement. And hence it is used in a wide variety of situations. These situations, just like as a some cases in physical modeling, building simulation, transportation method, and raw material management. So these kinds of situations handled by the discrete event simulation, right? And for this case of ability to analyze the model, as it runs sets simulation modeling apart from the other method, such as those using different types of techniques, just like the discrete event simulation or the not discrete event simulation, right? And the next case is here. In the some points are given here. So in a simulation study, Human decision making is required at all stages. Human decisions making is required at all stages, namely model development, experiment design, output analysis, conclusion formulation, and making decision to alter the system under study. The only stage where human intervention is not required. The only stage where the human intervention is not required is the running of the simulations, which most simulation software packages perform efficiently for this case. And here the one important point is that powerful simulation software is merely a hygiene factor. Its absence can hurt a simulation study, but its presence will not ensure success, right? And experimented problem formulators and simulation modelers and analysts are indispensable for the successful simulation study. So for this case, we use different kinds of simulation for this purpose, and by being able to inspect, process, and interact with a simulation model in action, and both understanding, develop the trust for the simulation and different kinds of analysis, right? So this is a figure. This figure gives the different kinds of approaches, just like a figure 1. Here gives the simulation study systematics. Here is it gives the scenario of real world to the simulation study. Real world and the simulation study of problem. So this is the system. So this is the system under study, and this is the real world, and this is the simulation study. So this system under study just give the real world problem. So in this real world problem, just first you consider the example of the real world problem. If you want to construct any model or any device, first you go to the altered system, means just design modification of the system. Then you will perform the study. Then you perform the study, and this is the study just like a system under study case. So for this case, altered system. For this case, just you go to the this step, and if any problem, and it will occur again. So then you move to this again, this process, and this is a very complex process. This is a very complex process for this type. So in this case, just you move here to here, here to here, again and again, and this process is very time consuming process, and it will take very lot of time, money, and all things are, if system is not provide a success, so all things go in waste, right? So but in the case of simulation study, just you take the data from this system under study, and then put the data in the simulation model, put the data in the simulation model, and then first you create a model, and then go to the simulation experiment. In the simulation experiment, just you find all input parameters, all constraints explained in this section, and you will move to the simulation analysis. So here some simulation engineer provide the simulation analysis in the case of fluid fluent problem. So CFD engineer are used for this purpose. In the case of structural analysis, So suppose if case of the one dam analysis or the bridge analysis, this is done by the structural engineer. And if you want to study just like the transportation, send the goods from one city to another city, by the simulation use a operation research engineer or the quality control engineer, and then find the conclusion. And this conclusion gives the exact result. This conclusion it is sometimes give the hypothetical result, but this is this result just meet the all type of requirement. And then this conclusion provide this system under a study. So in this case, if system is failed, then this is good. If system is not failed, then this is okay. And if system is failed, then you again move to this simulation model. So these are the different types of studies for this case. And this figure gives the simulation study systematics, right? So then this figure gives a definition of this simulation. So simulation is the imitation or duplication of the operation of the real world process. Or system over the time, and it generation of the artificial history and observation of the observation history also. And here a model is construct a conceptual framework. That describes a system, and the behavior of the system that involves over time is studied by developing the simulation model. For this case, and the most takes here different types of assumptions we have taken. First assumption is here mathematical and the logical assumptions, and second is here symbolic relationship between the entities. For this case, and role of modeling and simulation. A model can be used to investigate a wide variety of what-if questions and about the real-world system, and potential changes to the system can be simulated and predicate their impact on the system. With the help of simulation, you can find the adequate parameter before implementation. Adequate parameter just like you find the force, how much load will occur, and in the case of transportation, and what is the minimum cost of the transportation. By the help of simulation, you can find this. So simulation can be used as a analysis tool. So for this purpose, simulation used as an analysis tool for predicating the effect of changes, and it provides a design tool to predicate the performance of new system. And it is better to do simulation before implementation. Right? So these are the different kinds of simulations. And when simulation is the appropriate tool. So simulation enables the study of internal interaction of a subsystem with complex system, and informational, organizational and environmental changes can be simulated and find their effect. And in the case of the simulation model, help us to gain knowledge about improvement of system, and it finding important input parameter with changing simulation inputs. The changing simulation inputs is here, and here are some other points are given for the simulation. So simulation can be used with a new design and policies before implementation. Simulation can be used with new design and policies before implementation, and simulating different capabilities for a machine can help determine the requirement. And simulation models designed for training make learning possible without the cost description, right? So it provides a way to change the system requirement, right? A plan can be visualized with animated simulation, and the modern system factory wafer fabrication plant service organization is too complex that its internal interaction can be treated only by the simulation only, and these are the some advantage and some disadvantage. So first we will take advantage first. So new policies, operating procedures, information flows, and can be explored without disrupting ongoing operation of the real system. So with the help of simulation, you cannot you cannot give any description of the of the real world problem, and you provide or you explain the good result in this case. And new hardware designs, physical layout, transportations systems, and can be tested without committing resources for their acquisition. And one more advantage for this case, and time can be compressed or expanded to allow for a speed up or slow down of the phenomena. And insight can be obtained about interaction of variables and the important variable to the performance. So here one bottleneck analysis can be performed to discover where work in progress the system is delayed, and simulation study can help in understanding how the system operates. So these are the some advantages for the simulation. Then go to the disadvantage for this case. These are the some disadvantage. Just like the model building requires special training. For this vendor of simulation software have been actively developing packages that contains models and that only need input. Suppose in the case of SAP programming. So first you learn the SAP programming and how to how to cover this programming here. And the next disadvantage for the simulation is simulation result can be difficult to interrupt. So simulation modeling and analysis can be time consuming and expensive process, and many simulation software have output analysis. Because of this, simulation provides a hypothetical analysis. So simulation provides a one hypothetical analysis for this case, and these are the some area of applications of the simulation. For this area of application of the simulation, these are the manufacturing applications, semiconductor manufacturing, construction engineering and project management, military application like as a weapon design, missile design, or in the defense sector. A lot of the simulation process are used, and some logistics, supply chain, and distribution applications, and distribution of goods from one city to another city. And in this present time, in pandemic time, a lot of simulation results are going on, and because of the transportation of vaccine from one city to any other city. So the transportation modes and traffic provide the simulation result, and the business process simulation in healthcare system. Suppose in the case of drug delivery system in the body, so how much time any medicine, how much time take to deliver the drug in the specific area, and the automated material handling system, and test bed. This is for test beds for functional testing, and of control system software, and the risk analysis also. This gives the insurance portfolio, and the computer simulation, just like the CPU or memories, and the network simulation, just like the internet backbone, LAN switch router, wireless, PSTN, and call centers. So these are the some other methods for the area of application for this case, and move to the next case here. These are the steps in simulation study. These are the different types of steps used in simulation study, and these here 11 steps are given to solve the simulation study. These are the steps in simulation study, just like for developing a simulation model, designing a simulation experiment, the performing simulation analysis. Our first step is here, identify the problem first. First you identify the problem and then formulate the problem. This is the second step, formulate the problem. Means formulate the problem gives the one all input parameters, and the collect the processes real system data, and step number 4, formulate and develop a model, and step number 5, validate the model, and step number 6, document model for future use. And step number 7, select appropriate experimental design. And step 8, establish experimental condition for runs. Establish the experimental condition for runs. And step 9, perform simulation run. Perform the simulation run. And step 10, and then move to the step number 10, interrupt the present result. And then step number 11, recommended future course of action. And then on the basis of these steps, we can divide the simulation models into the 4 steps. First is simulation of deterministic models. In the case of these models, the input and output variables are not permitted to be random variables, and models are described by exact functional relationship. And simulation of the probabilistic model, in such cases, method of random sampling is used, and the techniques used for solving these models are termed as Monte Carlo techniques. And the fourth method is here, simulation of static model. In this case, these models do not take variables time into consideration, and the simulation of the dynamic model just give these models deal with time varying interaction, right? So these are the different types of models for provide different kinds of analysis for this simulation. So based on these here these are some more advantages for the simulation. So simulation is a widely accepted techniques of operation research due to the following reason. So this is the advantages related to the only operation research purpose. operation research purpose. So it is the straightforward and flexible. It provides the analysis for a straightforward and flexible case, and it can be used to analyze large and complex real-world situations that cannot be solved by the conventional quantitative analysis model. And it is only method sometimes. This is the only method sometimes, and it studies the interactive effect of individual components or variables in order to determine which ones are important. And for the case of simulation model once constructed may be used towards the end again to analyze all kinds of different situations. And these are the some limitations by using simulation techniques. Since simulation model mostly deals with uncertainties, the result of simulation are only reliable approximation involving statistical errors, optimizations, and in many situations it is not possible to identify all the variables with affect the behavior of the system. And in large and very complex problem, it is very difficult to make a computer program in view of large number of problems requiring the use of computers. Simulation may be comparatively costly and time consuming in many cases. And each solution model is unique, and its solution and interference are not easily transferable to other problems which can be solved by other techniques. So these are the different limitations using the solution. So here is one solution. This is used in analysis for the operation research. This is the Monte Carlo simulation. So for this Monte Carlo simulation, Monte Carlo method is a simulation technique in which statistical distribution functions are created using a series of random numbers working on the digital computer for a few minutes. And this method is generally used to solve problems and which cannot be adequately represented by mathematical models, or where solution of the model is not possible by analytical method. So Monte Carlo simulation is a solution which should be very close to the optimal, but not necessarily the exact solution. But this technique yields a solution which converges to the optimal solution, as the number of simulated trials need to identify the Monte Carlo simulation procedures can be summarized in the following steps. So these are the for the Monte Carlo simulation. This is summarized by the two steps. First is step number 1. It clearly defines the problem, and second is construct a approximate model. So for this step number 1, just identify the objective of the problem and identify the main factors which have the greatest effect on the objective of the problem. And for the construct the appropriate model, so specify the variables and parameters of the mode. So formulate the appropriate decision rules, that is the state of condition under which the experiment is to be performed, and identify the type of distribution that will be used. And models use either theoretical distribution or imperial distribution to the state of patterns of the occurrence associated with the variables, and it also specifies the manner in which time will change. In which time will change. So this is a one problem related to the Monte Carlo simulation. So this problem I will solve in the next series of lecture, means lecture number 32. Right? So we move to the next set of problem of this lecture. These are the problem is MCQ problem related to this topic. We move for this. So all type of problem related to the MCQ problem, this simulation problem related to the transportation. So in the case, this is the first transportation related problem. The allocated cells in the transportation table are called, these are the four options is given: occupied cell, empty cell, unoccupied cells, and none of these. So the correct answer for this question is here, empty cells. So then move to the next question. Then question number 2. In a transportation model, VM stands for. VM stands for. These are the four options. A option is here, value addition method. B option, Vogel approximation method. C is Verginian approximation method. And D is the none of these. So the correct answer of this question is here, Vogel's approximation method. B is the correct answer for this problem. And then move to the question number 3. This is the third MCQ problem, and it gives the initial physical solution to the transportation problem can be found out by VM method, Modi method, both A and B, and none of these. So that solution can be found out by the VM method. The correct answer is yes, A is the correct answer for this question. And then we will move to the next problem. This is the problem number 4, and the blank step, and is applied to determine the optimal solution. First is NWCR, VAM, Modi method, and none of these. These are the four options of this question is here. So the correct answer of this question is Modi method. Modi method. This is the three option is correct for this question. We'll move to the question number 5. In the question number 5, a transportation problem is said to be unbalanced when total supply is not equal to the total cost, total demand, both A and B, and none of these. So if in the case of unbalanced problem, if total supply, this is not equal to the total demand. So this is the B option is right for this question. And then move to the next problem. Problem number 6. For a minimization transportation problem, the objective is to minimize the main objective here. The four option is given: profit, cost, solution, none of these. So the cost is the B option is cost is, this is the right answer for this question. So cost is minimized to solve the problem. And this is the MCQ problem. Here is MCQ problem question number 7. When the number of shipments in a physical solution is less than the number of rows plus the number of columns minus 1. So the solution is optimal, and there is a degeneracy, and the artificial allocation must be created, and a dummy source must be created, and a dummy destination must be created. So for this purpose, here is a dummy source can be created. Then question number 8. The stepping stone method is an alternative to use the northwest corner tool. Often involves placing closed paths with a triangular shape. Is used to eliminate the cost effectiveness of the shipping goods by a transportation route not currently in the solution, and is used to identify the relevant cost in a transportation problem. So correct answer of this C option is the right answer for this problem. And then move to the question number 9. In the minimization problem, a negative improvement index in a cell indicates that the solution is optimal. Total cost will increase if units are relocated to the cell, that cell, and total cost will decrease if units are relocated to that cell, and current interaction with one than the previous one. So the correct answer is here. C is the correct answer. Total cost will decrease if units are relocated to the that cell. And then move to the question number 10. In a minimization problem, a positive improvement index in a cell indicates that the solution is optimal. B. The total cost will increase if units are relocated to that cell. C. The total cost will decrease if units are relocated to that cell. And D is there is a degeneracy. So D option is right if there is a degeneracy for this case. And these are the references regarding this chapter. And thank you for your kind attention. Thank you all of you.